Okay, so today's lesson is on rate of change. As you saw it on the slide, rate of change is the rate at which dependent variable changes for one unit of independent variable. So that means the y variable changes for one unit of x variable. Now, the day before yesterday and yesterday you talked about speed in your distance time graph. What is speed? Speed is um, speed is the distance traveled by the time. So distance traveled divided by time. In other words, distance is always plotted on y-axis. So it's the change in y values divided by change in x values. This can also be represented by rise over run. This is something new which we haven't talked about it yet, and that is called the rate of change when we look at a graph. Now, when we say change, change can be represented by the symbol delta. This is called delta. Delta. So we can also write this as delta y over delta x. So that is called rate of change. And I often like to use the short form ROC for rate of change. Now let's look at some of the questions here. The following graph shows the cost of renting a banquet hall. Initially, the cost is $300 just for the hall. There is a per person cost in addition to cover the meal cost. How much does it cost for each additional person who attends the event? So now here we are finding the value for one person, the cost for one person. So for that, now we can do delta y over delta x. Now we can pick any 2 points. So if you see there are some highlighted points here, I'm going to pick this point and this point. And now let's see what is the change in y value from here. What is it going up by? This is called delta y. And for x values, how much is it going up by? This is called delta x. So now here, rate of change is delta y over delta x. So now if you look at your y-axis from 400 to 500, change in y value is 100 divided by delta x is from 4 to 8, which is 4. There is a change of 4. So this is equal to 100 divided by 4 is 25. So what does this mean? This means cost per meal or per person is equal to $25. Now this value is called rate of change or a unit rate, which is in this case cost per person or cost per meal, which means the same thing. Now let's look at another example, similar example, but now here the line is going downwards. The following graph shows the balance in Jenny's bank account over 7 weeks. She started with $300 in her account, but has been spending her money at a constant rate. Look at the word spending here, and we'll talk about what that means in a bit. So now here again, I'm going to have you figure out the rate of change. Rate of change is same thing, delta y over delta x. Now, you can pick any 2 points on the graph. It doesn't matter as long as you can clearly identify them, what they are. So I would pick this point, the starting point. The starting point is right here. And then I think I can clearly read this point. This point is 2, and the scale is going up by 20. So this is 2 and 260. My iPad is not behaving, sorry. Okay, so now here, let's see what is the change in y value and the change in x value. So here, delta y over delta x will be what? From 300 to 260 is 40, and change in x value is 2. But now here, what's happening? As this said, Jenny is spending money. So the money in her account is going to go down. So the value is decreasing. So it's minus 40. So what is negative 40 divided by 2? That is negative 20. So that means that she is spending $20 per month. Oh, not month, sorry, week. Because this is her over 7 weeks. So this value is called rate of change again because now we are talking about per week how much is she spending, and that's it. So for now, for the next graph, it didn't print very well. I just quickly made it, and we're just going to look at now the car consumption. Mrs. Boulanger's car mileage is represented by line A. Sorry, that was Mr. A. Boulanger, and Mrs. Boulanger is line B. So which car, how far can each car travel in 1 gallon? So again, because we are looking at 1 gallon now, we are calculating the unit rate. So for line A, I am just going to use, sorry, I'm just going to double check which one was line A. Yeah, so for line A, what will be the gas consumption for line A? I just picked this point. From here to here, it is delta Y, which is 50. So this is 50, and delta X is 5. So your line gas consumption will be 50 divided by 5, which is 10. And for line B, I picked this point here, which is 1 divided by 1. Delta Y is 1, and delta X is 1, so it's going to be 1. So which car has a better fuel mileage? So that means which car can go further with less amount of gas? That would be line A. So that means Mr. Boulanger has a better car mileage. $10, no, sorry, $10, 10 kilometers per gallon. Okay. This is again called unit rate, and in this case, it's miles per gallon. Oh, I wrote kilometers per gallon, so I clearly made a mistake here. So let's delete the K here. Okay. Now let's move on to the next part on the next page. That is talking about rate of change in more abstract questions. Those were more real life based questions. So here we were talking about delta Y over delta X, but now here we're going to look at the same thing because delta Y is looking at your Y values, so that's called rise, and delta X is on X values, so it's called run. So simply rate of change can be written by delta Y over delta X, and we have another name for it which is called rise over run. Now if we have to determine the rate of change for each of these lines, you can simply find 2 good points and find your delta Y over delta X, which becomes your rise over run, and that becomes your slope, or in this case, rate of change. So I'm just going to do one question with you, and then I'm going to pause, and I'm going to have you guys finish this sheet and then come back and check if you got all the questions right. Remember to look at the direction. If the line is going upwards, then it's a positive rate of change. If a line is going downwards, it's a negative rate of change. And we always read the scale from left to right. So you can see here, these lines right here are going upwards from left to right. These lines right here are going downwards from left to right, and they will all have a negative rate of change. So let's do one question together, and then I'm going to have you guys finish the rest of the sheet. So here, 2 good points would be in the first question, this point, and this point, because you can clearly see on the grid where they meet. So now here, draw your little triangle. Oops. This is delta Y, and this is delta X. So delta Y over delta x. So you simply count the number of boxes because this is just an abstract question. So delta y was 3 and delta x is 2. So your rate of change is 3 over 2. That's it. Done. Now I want you to pause the video and finish this sheet and come back and check your answers. Okay, so I hope you got all the answers right. How do you decide which 2 points to pick? It doesn't matter. You can pick any 2 points, but they need to be clearly visible on the grid, and also the reduced rate of change. So your reduced fraction should match with my fraction. That's it. That's how you calculate rate of change. Now we're going to talk about horizontal and vertical lines. What's a horizontal line? Horizontal line is a line that lies flat on the ground, and vertical line is the line which is not flat. So if you look over here on the side, this is a horizontal line, and that's a vertical line. Now, horizontal lines have slope 0, or in other words, rate of change is 0, because there is no delta y here. There is only delta x. And for vertical lines, the rate of change is undefined. Why? Because there is no delta x here now, we only have delta y. You cannot divide anything by 0, and that's why it becomes undefined. Now look at some of the practice questions here. Now these practice questions are again based similar to the one that we did on the previous page. So I want you to pause the video, try to do these questions on your own, and then check back and see if you got them right. Okay, so I hope you got your answers correct. And that's the lesson for today.